Okay, so how was the third individual assignment? So sorry for the correction uh, in Z because I mistakenly input 6 plus. So aside from that, there was no correction. Anyway, so in chapter 6, fluid flow measurement. So there are numerous number of devices used to measure the fluid flow. So in any of these devices, the Bernoulli's energy theorem is greatly utilized. So in our ano naman to? Okay, so katong tay naggamit na mo og coefficient of discharge sa midterm mentalito. So that was already in chapter 6. So akong i-explain sa tong coefficient of discharge. So the coefficient of discharge is the ratio, see this? So it is the ratio of the actual discharge through the device to the ideal or theoretical discharge that would occur without losses. So ang kanang makuha nato through the device, that is your actual discharge. For example, if we take so for example, katong venturimeter nga inyong nakuha, katong venturimeter sa midterm. So ang makuha nimo nga discharge ani, that is the actual discharge, QA. So nganong QA man, because you are using the device. So meaning, ang imong makuha sa mga measurement through the devices, that is the actual nga discharge. So our next experiment, experiment number 4, 5. So 4 is katong sa metacentric height. Og 4 to man 5 is kani. So makuha ninyo katong volumetric method, that is already ang actual discharge ang imo makuha adto, which is ang adto na sa experiment number 5. So unsa man tong sa experiment number 5, namoy kuan source of water. So ato inaon nga mao na imong source of water. So imong kuaon og imong kuanon siya sa graduated cylinder, imong tawa na. So basta ka na. So for example, mao ni dire ang tubig, imong timbangon ang graduated cylinder, then timbangon na pud nimo ang graduated cylinder with the water. So makuha nimo ang weight sa water. Then if makuha nimo ang weight sa water, katong makuha nimo ang volume sa water. So then timeman man nimo ang pag-increase.
Excuse me, sir. Naka-off ang imong mic, sir.
Ay, naisayop sa mic tayo sa madunggan ako?
Oh, sir, madunggan na, sir.
karon pa sir.
Ay,
Karon pa sir.
sige. So, balik ko na ha. So, so coefficient of discharge. So, it is the ratio of the actual discharge through the device to the ideal theoretical discharge. So, ang kaning theoretical discharge is mao ni ang discharge na makuha nimo sa katunga kaning equation. Mao ni mong theoretical discharge. Okay? Whereas ang imong actual discharge is katong makuha nimo ani nga experiment. Katong experiment number 5 katong i-explain na ninyo last time. Katong pag-discuss nato sa chapter 5, di ba nag-discuss ko ani nga experiment number 5. So ingat to. Or katong venturimeter, katong sa midterm nga kuan, midterm nato. So this is kanang how to measure the discharge. So ang imo makuha ani is mga Q actual. Okay, sa kani nga mga devices. So kani pod Q actual. Kay nganong Q actual man, that is the actual discharge nga imong makuha sa imong actual nga system. Whereas kani is in theory mao na imong makuha. So unsay kalahian nila? So sa theoretical discharge kani you do not consider the head loss. Okay? Wa kay head loss sa theoretical discharge. I mean, ani nga sa theoretical discharge. Whereas sa actual discharge, ang imong makompute na nga discharge diha is giminusan naman sa head loss. So meaning, mas gamay jud ni. It will be always lower. So that would mean that the actual discharge over theoretical discharge should be less than 1. Mao jud na kanunay. Okay? So it should be less than 1. Mao to sa katong inyong gi-answer nga CD which is equal to 0.98. So kuha na to kanang murag hapit na to sa correct nga answer, pero tungod lagi kay nagamit mo ang CD, inyo nang gi-consider ang kuan, ang head loss. So kato sa chapter 5 kay we are not considering head loss pa man. So the actual discharge may be accomplished by series of observations, usually by measuring the total amount of fluid passing through the device for a known period of time. So mao ni siya. Whereas the theoretical value can be accomplished using the Bernoulli's theorem, neglecting losses. So unsa man pod ang coefficient of velocity? So ang coefficient of the velocity, it is the actual mean velocity to the ideal or theoretical which would occur without any losses. So meaning kani against actual gihapon ni kaning velocity. So mao na ang katong makuha nimo sa katong equation nga katong gi-discuss last time nga y is equal to x tangent theta minus gx squared over 2v actual cosine squared theta. Kani nga equation. So ang VA ani, so kani actual velocity na. Okay? So unsa may kalahian sa actual ug sa theoretical? Naturally, ang theoretical velocity is katong sa equation nga square root of 2gh or katong v squared is equal to sayo. Or katong equal sa katong sa kinetic energy. So di ba h is equal to v squared over 2g. So that is the velocity theoretical. So kung imo na siyang i-rewrite, mao na ning mahug nga ingani. Okay? So mao ni. So mao nang pagkuha nimo sa velocity, actual velocity. So this is the actual mean velocity. Nganong mean man? Nganong mean man jud na? So the average velocity. Kay ngano man, for example sa hose, nakay hose sa tubig, di ba? Inig agas nimo. In this time, kung ato kanang pag-agas na, dili na ni sila equal ang velocity sa pag-agas. For example, ang kaning velocity diri nga part is not equal to the velocity diri nga part. But we take the average. So mao nang gitawag nato nga actual mean velocity. So mao na sadya kay, remember when we discuss chapter 5, we must have to have an ideal fluid. Pero in reality, wa man kay ideal fluid. Okay? So in reality, wa kay ideal fluid. Pero sa kaning mga problem solving na to, we are considering nga ideal sila. So that's why nahug siya nga theoretical nga velocity. So mao ni siya kani. Mao ni ang imong equation sa theoretical velocity. Kani makuha nimo sa actual velocity. In this kuan kani is katong sa figure nga kung imong may maklaro katong sa kani maklaro sa yellow. So kung mao ni imong kuan dira na host mao ni so kani this is your x and this is your y. So kay ubos man siya sa orifice mo na nga ang imong value sa y will be negative. So don't worry kay ang imong answer ni will be positive. So kay bali kung kita ato ni nga 2 meters ni ang imo i-substitute diri is negative 2 because this will be your datum kani dire mao ni imong datum. So ang ubos ana ni dia negative, di ba? Kay bali mo man imong x-axis. So ang ubos ana tanan negative. So man imong y dire axis. So positive imong value sa x. So mao na. Kaning angle nga theta, that is the angle sa imong for example in this kuan is orifice. So na may times nga ingani ang porma. So if this is your orifice, kibalingan ang tangke. So mayngan ang tubig. So kani siya dire, kani mao na imong theta. So mao na imong theta dire. So kung inclined ang imong orifice, so mao na nga times nga kay theta. So coefficient of contraction mao ni siya. So kabantay mo if this is the diameter, if this is the diameter kani mao ni mo diameter, kabantay mo nga ang kani nga redepita is gamay na siya. Di ba? It's because it depends upon the opening. So mas kuan imong opening, so mas gamay ang imong value sa imong CC. For example, ani, if it is a thick plate or rounded plate, ang imong kay diri pala man daan sa opening imo naman si jang gipagamay, so inigawas ana ni jam mo equal na ni si dire. So mo na mahitabo. So mo na nga ang CC sa rounded o sa thick plate is 1. So naroon ni sa libro sa gilisan niya. So for instance, it is sharp edge or square shoulder na kay value sa CC. What is CC? That is area of the gem. So in some cases it will be said nga area of the vena contracta. So yan na. So area of the vena contracta and kani is area of the opening. Pwede ba yun nga area of the nozzle or area of the orifice. So kana. So it is the ratio between the area of the vena contracta or area of the jet over the area of the opening. So mao ni. So it can be equal to 1 but it cannot be greater than 1. So ingana na siya. Okay. So the relationship between the three coefficients, so from the formula nga actual area times actual velocity, so kani makuha nimo nga C is equal to CC times CV. So okay. Mao to. So nakay tulo ka coefficients, device coefficients C or CD, then CV and CC. So coefficient of discharge, coefficient of velocity, and coefficient of contraction. So again, there is a relationship between the three, which is the coefficient of discharge is equal to the coefficient of contraction times the coefficient of velocity. So naka-given nga ni, pero usually given man ang unsa ni tawag na coefficient of discharge or kundi mo ipapangita. So there's no need to memorize the table. So there's a head loss with respect to CV and velocity. Remember that ang head loss nimo nahitabo kay tungod sa nanakay flow sa imong tubig. Therefore, the formula for the head loss is due to the velocity. So, take note that the actual velocity here is the actual velocity. So, it is the coefficient of velocity. So, 1 over cv squared minus 1 times the quantity of v squared over 2g. So, remember that this value here is also equal to the head. Okay? So, muna sa dyan. Kung kita na kay head, pwede na nagmuna na yung gamiton. Velocity head. So meaning, pwede nimo ma-substitute ang value sa 8q squared over pi squared g d to the 4th diha. Kay equal naman na sila. So, okay, first na device na to is orifice. So, what is an orifice? It is a small opening. So, usually circular, but not necessarily nga circle siya na square, triangular, etc. etc. So, kasagaran lang kay circular siya to maximize the area at the same time to lessen the friction at the opening. Dili friction ka ng losses at the opening. Okay, there will be larger losses if there is a sharp edge. So, mo na nga i-circular na kasagaran. So, okay. So, unsay example sa mga orifice? So, ang mata na orifice, kanang mugawas ang kuan, luha. So, kana small opening. Basta small opening na siya. Okay. So, for the orifice, maura ni ang imo mga equation. So, no need to memorize kay actually that is still Q is equal to CAV. Maura na siya. Kani, kibaw man ka nga ang unsa tong theoretical velocity. Diba? Theoretical velocity katong giingon ninyo ganina is 2gh. Area ni sa orifice kana kay naman kay C dire. So remember nga mahimo ng Q is equal to CC CV AO VT. Kay nga naman kaning CCAO mao na ang imong actual. I mean dili actual kanang area of the jet. And ang kaning CV o VT, that is your actual velocity. So, ang makuha nimo ana is ang Q actual. Okay? So, if wa ning C, if katura Q is equal to AV, di ba? Theoretical na siya. So, kung imo na siya kuan, so this means, it means nga kani is velocity nga theoretical o kani is area of the opening or the orifice. So, mora na siya. So, mora ni nga ang katong equation nga atong nahibawan sa sugdanan, mora na siya. Imo rang gi-substitute ang V nga square root of 2gh. So, imo rang gi-rewrite ang equation. So, imo rang gi-tanawa ang kung imong bubantayan ang theoretical velocity square root of 2gh. Ang actual velocity butangan na imong CV para ma-actual. So, mora na yung kalayan nila. Theoretical discharge area times velocity. Diba? Kay velocity man area times velocity. Theoretical discharge. Actual, butangan na nimog C. Diba? So, CA squared of 2G. So, ang H ni mo is equal to H plus kani VA squared over 2G plus PA minus PB over gamma. So, that is the H. So, sa ning H, this is your H. So, values for H in various conditions. So, kaning capital H. So, H will be H if your pressure is equal to 0. If na kay acceleration upwards, remember sa katong chapter 4, so na kay 1 plus minus A over G. If na kay pressure dira, so kato nakatunan sa chapter 2, if this is closed tank, so P over gamma. If it is closed tank and has multiple layers of fluids, then you add the what do you call that? The head. So, mara na siya. So, submerged orifice, there's a difference between the head. So, na kay upstream, na kay downstream. So, the difference of the head mo na imong H nga gamiton. So, your capital H is equal to H sub 1 minus H sub 2. So, contraction of the jet. So, okay na orifice of lower head. Okay, so, okay, nozzle, same ra. Area of the nozzle ray, kalahian. So, Python tube. So, name after the French physicist and engineer. So, Henry Python. So, kani, ang kalahian ni just sa piezometer, if you look into this one, the piezometer is kaning A. This is your piezometer. Okay? Katong sa chapter 2 nga atong nakatunan. So, piezometer, if you remember, it only measures P over gamma or the pressure head. Diba? It only measures pressure head. Look at the Python tube. It measures pressure head plus velocity head. So, mao na siya. Okay? So, mao na ni. Mao ra nang kalahian nilang duha. So, this is your EGL, this is your HGL. If there's a distance traveled, di na sila equal. Tanawang A ug sa C, di na sila equal na nakay head loss. Okay? So, kani kay nagbali naman siya, di ni siya ma-compute ang unsa na ang velocity, so mo nang mas gamay siya dire. So, meaning against the flow siya. So, here you have a Python tube in the pipe. So, makuha nimo, ma-determine nimo dire, ma-appeal nimo ang velocity. So, gates, di na na. Okay, so unsteady. Okay, so sa unsteady flow, murag duha ra ka topics sa fluid mechanics nga i-consider nimo ang as hydraulics nga unsteady dili sa orifice ug sa wears. So after ani nga topic wears man, so if you look closely, if this is your tank, so there's a different elevation already. As the flow continues, as the discharge continues to flow out from the tank, and ato inaon nga wa kay Q in, so ang imong level sa water dire is mo padong ubos, di ba? If ang katong sa steady flow or constant head, murag kasagaran na is constant head man. So mahug na siya nga constant head kay tungod ang imong Q in is equal to Q out. Okay? So mo na atong trabahoon sa chapter experiment number 6. So maybe by April 6 magsugod na ta sa mag-send ra ko sa inyong mga schedule. So sa experiment number 6, constant head atong i-consider. So dapat ang imong Q in must be equal to Q out. Okay, so mo na ang kuan. So meaning your head will not change. Kay kung unsa na to musod diri mo ra may mogawas. If mas dako na ang mogawas kaysa musod, meaning mo naman siya kaubos. Pero if mas dako ang musod kaysa mogawas, mo naman nig saka. So di ba nga naman na. So dire ang makuha nimo sa kasagaran ani is with this the time value, because you need to determine the amount of time in order to lower the head from point 1 to ato inaw nga point 2. So that means that there is change in the volume. So, di ba? So, dV is equal to Q in minus Q out dt. So, if we rearrange this one, it will become dV over Q in Q out. So, we take the derivative. So, it will become dt is equal to AS. So, times dH. So, your AS there will become constant because what is varied in this is the head. So, Q in, Q out is the same. So, mo na nga, if we take the integral, para makuha na to ang time, so from H1 to H2, AS dH, Q in, Q out. So, nga na na siya. So, there's a formula for constant cross-section, kani. If constant ang cross-section sa imong tank. Pero if di ganin siya constant ang cross-section, kani dyan imong gamiton. Okay? Or kani, depende. Okay, if this is kuan kung wa kay Q in, so kani ra may mo gamiton. So again, if it is constant. Kay there are times nga dili constant. For example, your tank is a frustum. Ingana. Di ba mo naman og kagamay ang imong cross-section? Or maski mo yung kag hemispherical kuan tank ingani. So ang imong cross section dres imabaw is the greatest mo naman siya ka gamay. So there's a variation in your cross section, so that's why you have to use this equation or kani. So okay. Okay. So, last topic sa chapter 6 is the where. So, mo ni ang pinakadaghang formula. So, ang katong first na to nga mga topics discussion karon was to determine the flow in pipes. Pipes to tanan. Karon this is the flow in channel. So, open channel. Kana si kani. So, okay. So, mura ni siya inganig porma. So, kung nakakita mo sa kadtong kung sa tawa na where is flow. Kung nakikita mo sa kanang sa irrigation nito sa kanang itchon, imabaw sa itchon sa tong lugar. So, ingana example. Or pwede kani, ingani. So, this is the where. So, if what ning where, supposedly, constant flowing rin niya imong channel. Pero pagbutang nimo sa where, there's an increase in elevation kay tungod sa imong gitawag na hydrodynamics. Then that head nga sa pag-increase, that will be used in our solution. So there are classification of wheres according to the shape. So it could be rectangular, triangular, trapezoidal, and circular or parabolic. So in trapezoidal, there's a regular Cipolleti wear and a non-regular nga trapezoidal wear. So there's okay. So contracted wear, crest of the wear is the top. So katong ganina, katong ningana, the crest of the wear is kanina dire. So the overflowing stream in the wear, this is the knob. The contracted wear, this is contracted wear. Kay imong gipagamay siya. And this is equal to 0.1 H. Okay. Kana. So, basta i-value ani ni dire is 0.1 H. So, that is for contracted. For suppressed wear, if that is your open channel, igura ka nagbutang diha, that is your suppressed. So, this one here is only good for rectangular nga wears. Okay? So, sa rectangular na. Drop down curve, the downward curve of the liquid surface before the wear. So, namanay kuan, namanay okay, nara. So if this is your wear, nara man di ay. So this is your nap. Okay. So head is the distance between the liquid surface and the crest of the wear. So mao ni imong head. Mao ni imong head. Gikan na jud dire padong dire. Okay? Dili ang entire depth sa tubig. Again, ang head dire sa wear, that is only from the tip of the crest padong sa tip sa imong kuan dire. So nama kay drawdown. Drawdown is due to the head loss padong naman ubos. Okay, so mo naman siguro. Okay. Okay, so dire na kay consider nga velocity approach kaning HV, that is your velocity approach. So mo ning daghang memorization. So karon mo di man jud mo mag-memorize kay open notes man tanan natong exam. Pero usually sa board exam mo ni ang kinadaghanag memorization kay every shape has its own formula. So example for this one, for the actual discharge of a rectangular wear, assuming that there is a velocity approach, it will become this one. Q is equal to 2/3 C squared of 2G times the length of the wear. So this is the length of the wear. If we are talking about the wear, the length of the wear, mao na. But if we are talking about the channel, it will become the width of the channel. Okay, di ba? Mura man na siya gingana. Di ba? This is your channel. So meaning this is the width of the channel. This is the length of the channel. But if we are talking about the wears, it is the length of the wears. So kani, if you are considering the velocity approach, kay naman kay velocity approach meaning na kay head sa velocity. Whereas if you are not considering the velocity approach, or if the ratio h over p is sufficiently small, so i-cancel ra na nimo ang kaning mga HV, so kani ang imong value. Where CW, kaning value sa CW is equal to kani. This is your CW. Or that is the coefficient of wear. So reminder, lain ang coefficient of wear o coefficient of discharge. Kay naara ang coefficient of discharge, di ba? Mao man ang coefficient of discharge. Ang coefficient of wear is 2/3 C squared of 2G. So that is your CW. Okay, so napakailan mo formula for contracted wear. So kani okay. So standard wear factor katong CW na kay Francis formula, Rebock and Chow, and the Bayesian formula. So Francis formula mao ni mong equation 1.84 times 1 plus 0.26 h over d squared. So if h over p is lesser than 0.4, unsa ning h o unsa ning p? Your h there is the head of the water, whereas the p is the head of the height of the wear. Okay? So kaning p dire sa equation, this is the height of the wear. If it is lesser than 0.4, then the value for SI or English is different, 1.84 and 3.33. Okay, so you have to memorize this. Kung napata sa kuan classroom, mao ni yung memorization. Napa, Rebock and Chow for English and for SI, and also the Bayesian formula kani. So mas taas pa jud ang formula ani nigabot na to chapter 7. So kani mo buo na lang ni nga formula kang Bayesian. So that is 0.5518 times the quantity of 3.248 plus 0.02161 over h. And also this is for SI. Ang English nasa usa ka libro. SI ra na siya. Katong kang SCOM nga hydraulics nga libro katong gihatag last meeting na nga tong English nga formula. unit. So again, you must not, if the given is English unit, you must not change that into SI or vice versa. Mo man yung gibuhat, so I will not check it. Sa kuan pa na kanang rongan dyan na masibag sa una ni Pipino rongan mi. So 1N contraction and 2N contraction sa contracted rectangular wares. So if you notice, the L prime is the actual L. So mana na imong L prime if it is contracted. So katong gingon ninyo nga 0.1 H, so sa usaan kani this is 0.1 H. So kung duha na ka 0.1 H. Okay? So na makay 2N or double contraction or double contracted or 1N or singular contraction or singular contracted. So mo ni. So kani imong L nga gamiton nga equation. Okay? So daghan na kang memorize nun. So okay. Kani. So for a triangular ware or a V-notch, so kani, this is your theta. So nakailaing formula for 90 degrees nga angle og napo kailaing nga formula og less than or greater than 90 degrees. So ani nga formula, you are going to use kani Q is equal to 8 over 15 C square root of 2G tangent theta over 2H to the 5 halves. Where kani nga value mao na pud mo CW sa triangular kana. So katong wear factor, coefficient of wear. So mao na pud mo CW. So for standard 90 degrees kani imong gamiton nga formula 1.4 H to the 5 halves. Kung English 2.5 H to the 5 halves. Okay. So mo ni imong equation nga gamiton. So basta kay mo ni ang equation nga gamiton kani siya we are considering L pa man kani nga L. So which is na error. So usually kani may gamiton. Kay we are using triangular V-notch ware man jud. So trapezoidal, sharp crested, actually you have only to add the rectangular section and the triangular section. So kana ra. So mora na siya. Ang namalahi ra is ang sa Sipoleti ware wherein you must remember this one. Kay na uban nga problem nga moingon ra nga trapezoidal ware having a section 1H is to 4V. So, matik na siya nga Sipoleti ware. So, mao ni imong gamiton nga equations. Okay? So, basta kay mayo na nga basta kana kay actually Sipoleti ware is also a trapezoidal ware but the side slope, ang side slope is mao ni. Okay? The side slope is 1 horizontal to 4 vertical. So, mao na siya ang equation nga automatic. Di na ka magingani. So, kani is the rectangular ware. If you take note the equation, CWLH to the 3 halves and kani, di ba? CWH to the 5 halves. Kani. CW tangent theta. So, Z na isang gigamit dire kaya kaning Z is mao naman Okay, so mao na siya. Okay, so kani for hyperbolic, di mo ko kumukuha na submerged ware. Okay, sometimes unsteady, so same ra ni siya o formula sa katong orifice pero lain na siya og application diri na pud ka sa diri na pud ka apply. Okay, so that ends chapter 6. So sa mga problems kani, so ang answeran nga problems will be sa katong SCOM next meeting na naman. So ang akong gustong buhaton ang inyong buhaton karon nga week wa sa laman kay Semana Santa man, pero if you have the time please study this one. Okay, kay you need to study this because this is the what's ni? This will be needed if we go to chapter 7. Kani sa chapter 7. Okay, there is chapter 7. So mas daghan na ba ning formula? Then magamit pa jud to nga katong mga una nga na discuss nato. So again, na mao ni ang gingon ninyo ganina nga orifice nga inclined. So this is your angle. So pwede ra ninyo studyhan katong ganina nga napoy lain-lain nga fluids, di ba? So this is application. Okay, so kung sa ito yung nakitaan, nakatunan sa una. So this one also, you have to add ahead. So kung sa ito yung nakatunan sa chapter 2, mabalik na dire. Okay, kung sa may na discuss. Okay, so nay uban nga formula nga ihatag dire within the solution, pero I don't like nga inyo nang gamiton kay usually mas daghan na mo daang formula. For example kani daghan na mo formula daan nga gi-memorize, then dugangan pa ninyo nga pwede naman og if you know the basic. For example kani sibaw naman mo unsa ni this manometer, this is kuan, so you don't need to memorize additional formula kay inig board exam mas daghan kag formula, mas daghan kag makalimtan. So ang buhaton, you must know the basic kay mo naman ay kuan basta kay bawo kas basic makakuha makayani. So di ba, this is another solution, this is shorter, but the problem is do you want to memorize this long equation formula, whereas diri wa kay formula gigamit nga naman Bernoulli's energy equation. Then chapter 2 katong manometer mao man so Bernoulli's energy equation and the manometer, then you can get the answer. So kibali mga nakatunan na ninyo sa inyong past nga klase, whereas kung kani mag additional kag equation, so na kay usa kay ngana napakailain ni ngani. So you will be in a disadvantage, although shorter ang inyong solution kay right direct substitution man ka, but the problem is this formula will not be given in the board exam, so you need to memorize. Whereas kani look at this, wa kay memorize on. Basta kay bawo ka sa basic sa Bernoulli's energy equation, kay bawo ka sa basic sa pressure head, you don't need to memorize anything. So kibali di na ka mag-memorize ana. So clue di ay kung unsa to nga tubig or unsa to nga fluid nga nasa imong orifice. So for example kani if kay this is water man, so meaning everything must be changed in terms of water. So kani if you notice, but if this is mercury, then you have to change everything in terms of mercury, not water. Kung unsa to nga fluid nga nasa orifice or nasa opening, you have to convert everything into that fluid. For example, kung oil ni, i-convert tanan into oil, dili water. Okay? Kay mo na kasagarang kasipyatan. So for example, kanay glycerin. So look at this. It has been converted in terms of glycerin, not water. Okay? That is very important kay mao jud kasagaran nga karongan diri sa chapter 6. Then unsa pa man karon ini kakuan. Okay, so kani for example kani ito na i-discuss. Okay, mara man siguro. Okay, I think question. Questions. Okay, where? Okay, so any question? So our next meeting will be, okay, so we will not meet next week because that is Black Saturday. So we will meet the week after that. So we will meet on April 10 for this one. So I will give you examples in chapter 6, then afterwards we will start in chapter 7. Then April 17 will be your IA 4, then IA 5 for April 24. Okay. Okay, so aside from that, so changes lagi sa schedule kay our time will be changed next tomorrow. So we will move back by 1 hour. So from UTC 1 we are 7 hours you are ahead of us 7 hours. So next week we will be ahead by 6 hours na lang. So there will be a time in the schedule. I will just tell you when our start of class will be. So I think it will be 3 p.m. or 5 p.m. So ato ra na mahibawa next week. So aside from that, regarding the simulation, so I told you nga it will be a single PDF file. So most of you, I don't know if it's most, I'll check. So most of you submitted in document file. See? So I will not check those who submitted nga document file. Kaya ang problema lagi, nag-open ako ma-edit. So it will be hard for me to check. So it will be much better if it is PDF kay di na siya mo lihok. So I think I also put it in the instruction that it will be in a single PDF file. Okay, so I think that's all. So if you don't have any other questions, so thank you for coming. God bless. Bye bye.